Okay, for topic 4, we're going to talk about multiplying and dividing real numbers. And just as a quick reminder, we need to go over the rules for multiplying and dividing two integers. So the sign rules for integers apply to multiplying and dividing any real numbers. Okay, so let me remind you of what those rules are. When you're multiplying and dividing two numbers with the same sign, we get a positive result, so a positive product or quotient. And when you're dealing with different signs, we get a negative results. So if you haven't practiced topics 1 through 3, go back and practice topics 1 through 3 before you dive into topic 4. Another thing that we need to review or remind ourselves of would be the division properties of zero. It may have been a while since you've seen this, but there are two properties that we need to always remember when it comes to dividing any kind of division involving zero. So if you have 0 divided by a number, that result is going to be 0. If you have a number divided by 0, that is undefined. Division by 0 does not work. Okay? So a silly way to remember this is think of your division in fraction form. If you have 0 divided by a number k, think of that as okay. So that's okay, it works. The result is 0. If you have a number n divided by 0, think of that as no way. So kind of think of it as peppy. Okay, no way. It's a little rah-rah, but it is an easy way to remember which one is okay, which one is not okay. Division by 0 can't happen. So 0 divided by a number is just 0. A number divided by 0 is undefined. Okay? And then there's another spot in here because we're going to have to potentially talk reciprocal. It says to find a reciprocal, or technically that's called a multiplicative inverse. That's like a super formal official name for a reciprocal. Write the number in fraction form and then invert the numerator and denominator. We talked about that when we talked about fractions in a previous video, but just as a quick reminder. All right, so example 4, it says find each product, okay? So first up, we have negative 4.25 times 3.6. So we know that we're multiplying two numbers with different signs. That means the product is going to be negative. And then as for the multiplication, let's practice this by hand. When you're multiplying decimals, you just line them up on the right-hand side. You don't have to line up the decimals like you do with addition and subtraction. Just right-hand align everything. And then multiply to start as if there are no decimals there at all. We'll deal with the decimals at the end, okay? So I'm going to start with this 6 and 3.6. I want to multiply it by each digit in 4.25, starting in the ones place, moving backwards. So 6 times 5 is 30. I want to keep a 0, carry a 3. 6 times 2 is 12, and then 12 plus 3 is 15, so I keep a 5, I carry a 1. 6 times 4 is 24. 24 plus 1 is 25. All right. So now what I'm going to do is I'm going to multiply by the 3. And remember, we're pretending there are no decimals here. So technically that 3 is in the tens place. So technically I'm not multiplying by 3, I'm multiplying by 30. But that's a little bit harder for us. So we just put the 0 and 30 here. And then we can multiply each of those digits in 4.25 by 3. Okay, so that 0 is kind of like the placeholder. It's multiplying by the tens place. And if we had another digit, we'd be multiplying by the hundreds place. We'd put 2 zeros. But for now, 1 0 placeholder is fine. And then 3 times 5 is 15. We get rid of the 3 we carried before, and we carry a 1. 3 times 2 is 6. 6 plus 1 is 7. And then 3 times 4 is 12. We don't need that 1 because that was from the previous multiplication. So 3 times 4 is 12. So I just get, these are called partial products, so I'm going to add these together. So I get 0, and then 5 plus 5 is 10. I carry a 1. 5 plus 7 is 12, plus 1 is 13. I carry a 1. 4 plus 4, or 2 plus 2 is 4. 4 plus 1 is 5. And then drop down the 5. And here's where you have to address your decimal, okay? We look at how many decimal places we had in our factors. We had 2 decimal places here. We had 1 decimal place here. That is a total of 3 decimal places, which tells us we need 3 decimal places in our product. So I want to go back 1, 2, 3. And this tells me this is negative 15.300, but we would generally just write this as 15.3. So there's your final answer. So you could certainly check this with a calculator, but I do want you to get in the habit of being able to do some of this calculation work on paper because sometimes it really is just quicker. All right. So try to remind yourself how to multiply decimals. That's an example. All right, let's talk fractions. So for part B, we're finding a product still. We have -1/2 times -8/15 times -9/11. And if you go back to the previous video, we talked about multiplying a series of numbers. And what you do is you just add up the number of negatives. So I've got 1, 2, 3 negatives. And anytime you have an odd number of negatives, it's going to give you a negative product. Basically, two of those negatives pair up and become positive, and then you have that one leftover negative that makes everything negative. Okay? So we know that the result here is going to be negative. Now we need to multiply, and you have to kind of go back and remember how to multiply fractions. When you're multiplying fractions, you want to look for common factors top to bottom that could be canceled out. And as you work with this and you get more confident with your multiplying of fractions, it becomes a bit easier, but for now I'm just going to rewrite this problem and I'm not going to worry about the negatives. We know the final result is going to be negative. We've already played around with our signs. So I'm going to look at just the numbers. Whoops. I can rewrite these numbers as factorizations. And remember, a factorization is just a way of writing a number as a product. So I'm going to leave 1/2. But then 8, I'm going to write it as 2 times 4. And 15, I'm going to write it as 3 times 5. And then 9, I can write as 3 times 3. And then 11 is prime, so we're just going to leave it 11. Okay? So now we want to look to see, are there factors top to bottom that are the same? If so, they cancel out. They really just divide out and become a 1. So 2 divided by 1, or 2 divided by 2 is 1. 2 divided by 2 is 1. Those 2's cancel. 3's cancel. 3 divided by 3 is 1. 3 divided by 3 is 1. And now in the numerator, I have a 1, a 4, and a 3. In the denominator, I have 1s and a 5 and an 11. Nothing else will cancel. So I want to multiply across. So I get 1 times 1, which is 1. 1 times 4 is 4. 4 times 1 is 4. And then 4 times 3 is 12. And then for the denominator, I get 1 times 1 is 1. 1 times 5 is 5. And 5 times 11 is 55. So we get -12 over 55 as our final result. So you're mixing two things. You're mixing the idea of just multiplying fractions with that idea of multiplying integers where those negatives get thrown in. Okay, let's practice division. All right, so example 5 says find each product. Now, dividing decimals is probably the hardest part of dealing with decimals. It's not the hardest thing in the world that you're going to do, but as far as operations with decimals, division is the hardest. But let's go ahead and remind ourselves of how it works. So we have 45.36 divided by -7.2. There's this thing with division where you have your quotient, you have your dividend, and you have your divisor. The number that's being divided is called the dividend. So 45.36 is our dividend. The number that's doing the dividing is called the divisor. So 7.2 is the divisor. And we have this rule that we need the divisor to be a whole number. Well, 7.2 is not a whole number. So technically, if I multiply 7.2 by 10, I can move that decimal to the right once, making this 72. But if I multiply the divisor by 10, I have to also multiply the dividend by 10. So if I multiply the dividend by 10, it gives me 453.6. Okay, so now this is what I'm really dividing. 453.6 divided by 7.2, it's going to give me the exact same result as if I just flat out divided 45.36 by 7.2. Okay, so let's set this up for long division. Well, let me do it over here so I have room for some side work. When you're dividing, the dividend can be a decimal, that's fine. We want to just bring the decimal up into the answer. And then we have to start the dividing. And it can be a little bit challenging, but if you're good with your multiplication or at least estimating, you can get through this. So we want to know how many times 72 goes into 453. So I start by kind of estimating. I'm like, well, 72 is close to 70. 453 is close to 45 or 450. So then I really ask myself, how many times would 7 go into 45? Well, 7 would go into 45 6 times. So let's just start there. Let's see what 72 times 6 is. You do a little side work. Well, 6 times 2 is 12. I carry a 1. 6 times 7 is 42, plus 1 is 43. So that was a really great estimate. We're like, okay, using our skills with estimation, we think 72 could go into 453 6 times, and that is true. 72 goes in 6 times. We want to multiply 72 times 6. That gives me 432. I want to subtract that. So 3 minus 2 is 1, 5 minus 3 is 2, 4 minus 4 is just 0, so we don't deal with that. I want to bring down the next digit in line, which is a 6. So we're going to do that estimation thing again. So 72, we're going to think it's close to 70. 216 is close to, let's say, 22. And then just think, okay, how many times would 7 go into 22? Well, 7 would go into 22 3 times. So let's see if 72 will go into 216 3 times. So we take 72 times 3. Well, 3 times 2 is 6. 3 times 7 is 21. So it happens that 72 goes into 216 exactly 3 times. So I want to subtract my 216. I get that 0 remainder. That 0 remainder is awesome because that tells you your division is done. And so now we can go back to the original problem. We had positive 45.36 divided by negative 7.2. So that tells me this quotient's going to be negative, and it's going to be negative 6.3. And that's it. Okay. So again, there's power in knowing how to do things by hand. Yes, you have a calculator. Yes, you can use your calculator, but practice doing some of this stuff by hand because sometimes it really is just going to be quicker and easier to just jot things out really quickly by hand than stopping what you're doing, digging out your calculator. In the process it takes you to dig out your calculator, figure out what that division is, you've lost the rhythm in that problem. Okay, let's look at part B. So we're still looking for quotients. Part B, though, we have 2 fractions. Both are negative, so that tells me this final result is going to be positive. Okay, so I'm not going to deal with the signs when I do my actual division. I just remember that I'm dealing with 2 negatives. The result is positive. So for my side work, I have 2/3 divided by 5/4. Well, if you go back to this idea of multiplication, we don't know how to divide fractions, but we do know how to multiply. And I can convert division to multiplication by leaving the first fraction the same and multiplying by the reciprocal of the second fraction. So the reciprocal of the second fraction is 4/5. Okay, so I want to see if there's anything I can cancel top to bottom, and there isn't. In the numerator, I have 2 and 4. The only factors there are 2s and 4s. In the denominator, I have 3 and 5. They're both prime, so those are the only factors. Nothing is going to cancel, so I just get 8/15. And remember, if we go back to the original problem, we were dividing 2 negatives, which would make the final result positive 8/15. That's it. Okay, so definitely get some practice in with multiplying and dividing fractions and decimals. Okay, finally, we have example 6. It says find each product or quotient, and here we're specifically dealing with zeros. Okay, so for part A, we have 15 times -6 times 0. Now, if you're multiplying, anytime you have a product involving 0, the result is going to be 0. Okay, so if any of your factors is 0, the whole product becomes 0. Okay, we have the multiplication property of 0, which tells us that. So let's just pretend that we had -6 times 0. That's 0. 15 times 0 is 0. We don't have to do any work here because we have one 0 factor. The whole product is just 0. Okay. Now we have division, so we can practice that. Okay, no way. So I have 0 divided by a number. So that's the okay version. That tells me this is just 0. It doesn't matter what that number is. If it's an integer, if it's a whole number, if it's a decimal, if it's a fraction. Anytime you take 0 and divide it by a number, the result is going to be 0. And then finally, we have -36 divided by 0. So this is the no way version. You got a number divided by 0. Can't happen. We would say this is undefined. So remember, the word undefined goes with division by 0. So make sure you take some time and practice multiplying and dividing real numbers. Remember the rule.